Practice question 3 in week 2 requires you to complete lab exercise 2 from that week's lab exercises, and this requires you to do various things with Excel's random number generator through the data analysis tool, and then also answer a few questions that relate to the central limit theorem. So part A, to get things started, requires you to generate one sample of 100 values from the uniform distribution with parameters of 0 and 10. So in Excel, that will involve data analysis, random number generation. Number of variables is the number of samples. We want one sample. Number of random numbers is 100. The distribution that we've been asked about is the uniform distribution. Its parameters are a low value and a high value, in this case of 10. And I might get Excel to give this to me in this particular sheet that I've got open. I'm going to click up here. Notice that I ignored this random seed, and now OK. And Excel should have randomly selected values between 0 and 10 and 100 of them. So if we just scroll down, we'll find that yes, it did. It has picked 100 values. And the next question says, find the average and standard deviation of these 100 random numbers. So the mean, the function we use is average. So I've typed equals average. I'm going to click on this first cell, and then I'm pressing Control, Shift, and the down arrow key, and that automatically selects all the cells that are in a contiguous range. And then I'll press Enter, or maybe close brackets and press Enter, and I'll have the average value of 5.02 of those 100 scores. And we'll do the same thing to find the standard deviation. The function here, I'm going to assume that's a sample, so I'll do stdeb. Again, I'm going to click on the first cell in the range and then press Control and Shift and the down arrow key together, and then hit Enter. And Excel has produced the standard deviation of those values for me. The question says, how do these compare to the parameters for the theoretical probability distribution for this uniform distribution, which would have a mean of 5, exactly halfway between the low value of 0 and the upper value of 10. And if you looked at the one of the handouts in this week's workshop that summarized various theoretical probability distributions, it showed that the variance, in fact, for the uniform distribution is equal to its high value of 10 minus its lowest value of 0, all of that squared and then dividing by 12. So that produces the theoretical, or the variance for this probability distribution out of which we'd been randomly selecting our values. That's the variance. To get the standard deviation, I'm just going to find the square root of that using Excel's sqrt function. And that gets me this value of 2.8867. And you can see that the sample of 100 that we selected, the mean of those values, the sample mean, is very close to the population mean of 5. And the standard deviation for this sample of 100 of 2.73 is quite close to the population standard deviation of 2.887, let's say. So on these grounds, it looks like the sampling process has mimicked the overall population distribution quite well. Part C then asks us to produce a histogram of these random values that we've come up with, and that also is going to use Excel's data analysis tool. It says to use bins of 1, 2, 3 up to 10. I've started a sequence. Excel will be able to see that I started at 1 and I've gone up by 1 to get to 2. If I hover over the bottom right hand corner of those two values, and then drag downwards, Excel is able to guess the sequence that I was interested in, and it just auto completes it for me when I fill down. And now to do the histogram, I'm going to go Data, Data Analysis, Histogram, OK. The input range, again, I'm going to select that first one and then Control and Shift and down arrow key. It selects the 100 values. The bin range was back up here. I could do the Control Shift down trick again, but seeing as I can see them all, I'll just manually select them. And why don't I produce the output here in this very sheet? Careful to click down here in the output range. I will get it going here in D4, and I want it to give me some chart output as well as a frequency table. The frequency table is a default, the chart output is an additional output that we can select. Okay, so there's the frequency table there. It's telling us that there are 11 values between 0 and up to and including 1, and then a fraction above 1 right up to and including 2 there are 3 values, and so on. The graph of the histogram shows something like what we would expect. If we were to increase our sample size to a very large number, it should be the case that within each interval we would expect to see the same amount of observations, or the same relative frequency if we've been drawing a relative frequency graph. So that would mean that they would all be at about this level here. And the uniform distribution looks like a rectangle, roughly. So this doesn't look too far away from that. In our sample, we didn't see very many observations between 1 and 2. And we saw a few more than we might have expected in the range of 6 to 7 and some of these other ones that are above 10. But there's always variation in random sampling, and this doesn't look too far away from what we would expect in a very large sample size. Part D requires us to generate some more random numbers, but this time rather than one sample we're going to do 20, and well, let's just get straight into that. Data analysis. We want to again generate some random numbers. This time we want to generate 20 different samples, and in each of those samples we only want to this time to have 50 values. Still the uniform distribution, still the same parameters, low value of 0, high value of 10. This time I think I'll produce the output in a separate sheet, and I'll call this I'll call it Part D, seeing as that's what we're doing, and fire away. Okay, so hopefully then we have 20 samples along this way and 50 in each. I'm just going to quickly insert some cells here, so I'm going to highlight those 4 and just right click and then insert. Then I'm going to insert some cells or some rows above, so I'm going to select all those rows, highlight them, and press insert. Sorry, right click and then press insert. Now let's just see 1, 2, 3 samples. If I drag that across, hopefully it stops at 20 samples. Yep, good. And how many observations were there within each sample? We asked for 50. I don't expect Excel will have let us down here. And surely enough, no, it hasn't. Okay, the next question says calculate the mean for each of the 20 samples that you generated. So that means we want to find the mean of this first 50, and then the mean of the next 50 separately, and so on. So I might do this above here. The mean function is average, and then I'm going to click on that first cell, Control Shift down, and then enter, and the mean has been calculated for the first sample of 50. And then that formula, it's fine to just keep everything with relative references, I'm going to fill that across, and I've now simply calculated the means for all these other samples of 20. You can see in the second last one, it seems to be referring to the right cells, and I just go down to the last cell. Yeah, perfect. So I just double click there on that formula just so that I could see that it was calculating as I was expecting it to do. Okay. Then part F says calculate the mean of the sample means generated in E and the standard deviation of these sample means. So now it wants us to consider this set of values, and it says, well, they're all sample means based on a particular sample drawn out of a uniform distribution. And it says, the question is, what is the mean of those sample means? So I might put that there, mean. So again, it's the average, but this time, all of these values to the right, I'm going to go Control Shift and then arrow right, and then enter. And the mean of all those sample means is just less than 5. We're also asked for the standard deviation. I'm going to assume that what I have here is a sample, so I'll use the sample version of the standard deviation formula. Again, I want to find the standard deviation of those 20 sample means, so Control and Shift and right arrow, and then enter. And we've got ourselves the standard deviation of those sample mean values. And the question following this says, compare your results with the values predicted by the central limit theorem. So, what exactly is the central limit theorem? Well, I'll leave that as an open question. Maybe you can investigate. There was a few notes on this in the lecture, and you'll definitely find reference to it in Appendix A of the textbook. I'll come back in a second video, just finish off this question and starting that finishing off process by talking about what the central limit theorem is.